Okay, this is my new method for marking out a sphere as for turning into any of the Platonic solids. So I've got a scale, but you don't need a scale, and I've set it to the radius of the sphere at the 6 mark, the 6 divisions, because if you divide, when you divide a sphere by 6, it's just the radius goes around it 6 times. Then I've set a compass to 4. So you could pick any point on a sphere. I'm going to pick the one of the cardinal points because they're already there, and mark a little arc, and from that arc mark another arc, and then mark back to the first point, and from the second arc mark back to the first point and the second point, and you've got a right angled triangle. It's the only right angled triangle on a sphere is with 3 great circles, which is what we've got here. And I'll stop thinking about a sphere as a sphere. I'm thinking about it as 3 intersecting circles, an equator, a north pole, a south pole, then a 0 degrees of latitude, and then a 90 degrees of latitude going around the other way. So it makes it so much simpler. So you mark on the 3 points, and then you can find all of the other of those key intersections, 6 of them, just by going round and making intersections. So you'll have your sphere then divided into 8 parts by 6 points, and that would give you the 8-sided shape is a octahedron. So you could turn an octahedron by finding the centres of those 6 triangles, using those as your axes, and you can turn an octahedron. You can turn a cube just by using those 6 points, because they're the 6 faces of your cube from there. Now for the icosahedron and the dodecahedron, this is the method. From one of those points, so you've got your, set this to 10 divisions. I'm a bit short. And from each of those, well, from one of those points, come out and mark 2, and then opposite it mark 2 in the same axis. Then from one of the other, so this is from our 90th, I'm going to mark 2, and opposite that I'm going to mark 2 in that same axis, so on that same great circle. And then from the one that we've got left, mark 2, and then mark another 2 from the pole, you know, those things, those intersection points. So we've marked now 6 times 2, which is 12, and what we've done is constructed this shape, which is 3 intersecting golden rectangles, which is, staring at this made me realise this way of marking it out is so much simpler than any of the other ways. And that's it. We've got two points, look, and then around that 1, 2, 3, 4, 5, the same distance away, and however we look at it now, we've got that same. So we've got either the faces of a dodecahedron or the vertices of the icosahedron. And if you find the midpoints of those, which is quite simple using a compass, that's the vertices of the dodecahedron or the faces of the icosahedron, and it really is that simple. And there's no need. The old method, if you look back at my other video, was really messy, and these could end up in a right mess with lots of holes in where you've gone had to correct things. You know, one or two of them I ended up putting filler in and to fill in the holes. They were that bad. So it's a really neat. The reason this ball, this sphere, I've made using paper glue joints. So I'm going to split it in half now, or in a bit. I'm going to split it into 8 parts, and then I'll draw on the geometry of it, which is a square, which is your division by 4. You know, 1, 2, 4. And the golden rectangle, which is these opposing points. So yeah, you've got 3 planes through your sphere with a square and a golden rectangle marked on. That's what I'll end up with on the inside of this. And the reason I made it like this, I'm going to try and get some magnets so that this can be stuck together, and then I can take it in half, or take it in half another directional, and then that will show that geometry. So I'll do a follow-up video when I've done that. It won't be much of a video, and I'll also probably do a video on how to make a scale, a simple scale with just the things you need on to do spheres and Platonic solids in wood turning. Okay, thanks for watching.